before we go into the solution here, there is one question that often comes to our mind while we do this question, and for that matter, any question based on simple harmonic motion. Which equation should we be considering in for? Is that sine omega t or a cos omega t? Right? So it actually doesn't matter which equation do you take. For that matter, you can actually even take this equation x is equal to a sine omega t plus phi. And the solution doesn't matter, or it doesn't depend on which equation do you take. Irrespective of the equation you take, you should be arriving at the same answer, provided you have analyzed the question well and have taken the values given in the question in the correct physical sense. Okay. Now, why is it making no difference in the solution? Because if you take x is equal to a cos omega theta and x is equal to a sine omega t, not theta, omega t, you arrive at the same value of acceleration, which is minus omega square x, which is minus omega square x. And therefore, the variables in this question doesn't get affected by the equation. Now, let's see how. So, we have x is equal to a cos omega t. And when we differentiate displacement, we get velocity with respect to time. With respect to time, again, acceleration, right? So this is what we have here. Okay, now if you want to see how did we get this? Right, very basics of differentiation. So if x is equal to a cos omega t, what is dx upon dt? It would be a times d by dt of cos omega t, which is minus sine omega t times d by dt of omega t, which is equal to minus omega t derivative with respect to t is omega. So that becomes minus a omega sine omega t. Like this here. Right, minus a omega sine omega t. Now see, I'm not going much into the basics of differentiation here because that would take a whole lot of time to explain these very basic differentiation. Being in discussion on JEE mains topic, that too, which something which comes at the end of class 11th, I think I'm presuming the fact that you know differentiation well. Okay. All right. Now, so V will be minus a omega sine omega t. Acceleration would be again derivative of this. Derivative of sine omega t is cos omega t. Derivative of omega t is omega. Omega times omega is omega square, and that becomes minus a omega square cos omega t. Now, what is a cos omega t? Cos a omega t is equal to x, and therefore a is equal to minus omega square times x. Very similarly, when you have x is equal to a sine omega t, v is equal to a omega cos omega t, and a is equal to minus a omega square sine omega t. Why? Derivative of cos omega t is minus sine omega t, and derivative of omega t is omega times omega gives omega square. And again, what is a sine omega t? A sine omega t is x, and therefore a is equal to minus omega square x. Right? So yes, now things are clear with these two aspects. Now what we need in addition to these two formula is displacement as a position of time is a sine omega t plus phi. Therefore, velocity as a position of time is a omega cos omega t plus phi for any general equation. Oh yes, now I do understand that you have a doubt. How can we use this equation to understand to derive the value? I will do that as a separate solution Okay, but as of now, let's just focus on connecting these two values, x of t and variables x of t and v of t. Okay, please give me some time. I'm sorry, that is my bad. I should have explained it right away, but but I wrote it as a different solution. Apologies. Okay, now let's square this x of t is equal to a sine omega t plus phi. X of t square is equal to a square sine square omega t plus phi. Likewise with v of t. V of t the whole square is a square omega square cos square omega t plus phi. Right? Now, let's bring this a square to the LHS and a square omega square to the LHS in the first and second equation respectively. So what we get is x square by a square is equal to sine square omega t plus phi, and v square by a square omega square is equal to cos square omega t plus phi. All right? Combining these two, what we get is if you add LHS and RHS, sine square omega t plus phi plus cos square omega t plus phi is equal to 1. Why? Because sine square theta plus cos square theta is equal to 1. And LHS becomes x square by a square plus b square by a square omega square. Now, pulling out 1 by a square common here, what we get is 1 by a square times x square plus b square by omega square is equal to 1. And therefore, x square omega square, my bad, x square omega square plus b square is equal to a square omega square. If I transpose x square omega square to the RHS, a square omega square minus x square omega square, I can pull out omega square, which is the common term here, which becomes times a square minus x square, which is equal to v square. Taking root on both sides, what we get is v is equal to omega times root of a square minus x square. Right? Now, yes, see, this is the first question that we're doing on oscillations. So, yes, it's a very kind request that you make a note along with me. Right? And in the coming questions, when you go through the derivation a couple of times, when you write down it as well, then maybe you can just stick on to the formula and not the derivation every time. Right? But till it becomes natural to you, let's it's a very kind request that you make notes of this, very elaborate notes, writing it along with me. And for the revision, you don't need to do that, right? You can just skip these steps and go directly into the numerical part of it, which would look like this. You can take any equation of choice. Say v is equal to a cos omega t. A is equal to minus omega square x, and v is equal to omega times root of a square minus x square. Now, there is a very high probability that, see, I have to admit this, many a times I make mistakes by wherein actually the reason for mistake is that I swap a and capital A, which is acceleration and amplitude, something that we can address in the coming solutions. Let's see to make sure that I change the terminology so that the chances of mistakes become less. Okay. Yeah. So from the question, velocity is 2 meter per second, displacement is 4. So v is 2, x is 4, x is 4, and a is 16. From the first equation, a is minus omega square x. If I take magnitude of this, what I get is 16 is positive 4 omega square. Acceleration is 16, displacement is 4, and therefore omega square is equal to 4 and omega is equal to 2. Did I make a mistake here? Yes. Why? Because omega should actually be plus or minus 2. And I have neglected omega is equal to minus 2. And definitely the question stands, why? Let me see how many of you can give me the answer conceptually. Okay? Right. So yes, omega is equal to 2. Pulling this omega is equal to 2 into this equation, what we get is v is equal to 2 times root of a square minus x square. X is 4, 4 square is 16, 2 by 2 is 1, root of a square minus 16. 1 square is a square minus 16, a square is 16 plus 1 17, and therefore a is equal to root of 17, which means the amplitude of motion is root x, where x is equal to 17. Okay. Now what we'll do is we'll do the same question using this general formula. X of t is equal to a sine omega t plus phi, or x of t is equal to a cos omega t plus phi, and we'll arrive the same answer, because that's already what we have done here. But let us do that in a separate solution. Okay.